In this video, I'll show you how to create a Kubernetes cluster on AWS EKS using Terraform. Hi, it's Stefan from Deep Data Ocean, where we help you getting rid of your software monolith or your legacy software application. If you're new here, make sure to click the subscribe button, and all the links of the details I mentioned in the video are in the description below. So let's jump into it. Kubernetes is by far the most important container orchestrator. It's lots of effort to install Kubernetes on-premise. But it's way easier to do this using Amazon's EKS. In this video, I'll show you how to create an AWS EKS cluster using Terraform. This will give you full control over all resources needed, and it's also very easy to fully automate the deployment. And make sure to stick to the end of the video, since I'll have a free bonus for you. I'll show you how you can deploy several environments like dev, test and production completely automated using Terraform. With Terraform, you can describe all resources needed for your EKS cluster. This includes VPC, subnets, NAT gateways or internet gateways. I'm using Terraform for this, since you can really use this in a real-world scenario to deploy multiple environments like dev, test and production. So let's jump into it. In Terraform we have a couple of files. Let me start with the backend. So the backend is basically there for the organization of Terraform. So Terraform maintains a state that will be stored in an S3 bucket. So we need to create an S3 bucket with this name, and the file for this one will be tfstate eks.tfstate in my current region, and we have a DynamoDB table. So this is a semaphore, so when you're using this in a team and one starts the execution of this Terraform, then in this DynamoDB table there is a semaphore saying this guy has been started. So you cannot start it a second time when one run is already executed. So if you want to run this, you really have to create the DynamoDB table manually, as well as the S3 bucket. The second file is the provider, which just talks about how can we access AWS using Terraform. So it tells him the region, where to find the credentials to log onto AWS, and to which AWS account we are connecting. So then we need to set up lots of stuff for the network for the EKS cluster. The first one is the VPC. So here we're just saying we're having this network that we want to use to deploy the EKS. This VPC contains of 6 subnets, 3 private subnets and 3 public subnets in 3 availability zones. So an availability zone is basically a data center of AWS, so even if the entire data center is down, there are 2 other data centers that can serve the service. So here we're saying for every subnet, for the private, for example, in which availability zone it belongs and to which AWS VPC it belongs, and what this specific subnet is used from an IP address perspective. So here, as I said, we're having 3 private ones, and here coming the 3 public ones. As you can see, they look quite similar. The difference between them is, or the routing differs between them. So we're having 2 further resources, one internet gateway. This is an AWS resource that lets you access the internet, or lets the internet access inbound to the EKS. And the NAT gateway, which is for the outbound traffic. So here we're having the root tables. Here's the private one for availability zone A, or for subnet A, for the private subnet A. So every traffic from all IP addresses goes via the NAT gateway. And this is associated with the subnet private AZA. Then we have the same stuff for the private B and for private C. the public route table is only one, and this guy routes all the traffic to the internet gateway. And we're attaching, or we're associating these three public subnets to it. Then in order to be allowed to create EKS as well as the EC2 nodes for the EKS, we need to have two roles. One is the cluster role. So the cluster role basically allows to create and access the cluster afterwards. So it's a role that has this assume role, which is really essential, so that you can afterwards assume this role to use the cluster. And we're having the inline policy, or rather three inline policies for CloudWatch, for EC2. Well, to be honest, it's for three. For the EKS cluster and the policy attachment for that. And then we have it for the node group. So the script shall afterwards create EC2 nodes as the EKS workers and put them in a node group. And for this we need the role node group role with the name EKS node group role. That has now this STS assume role for the EC2. And a couple of policies are just attached here. Once we have done that, we can start creating the cluster by using the resource AWS EKS Cluster, where we have the configuration of the subnets. Well, we only want to start if the IMS role policy attachments are created, so that's why I'm having the depends on here. And I'm having some outputs that we're getting after the script has been executed. Once this is done, we can work on the EKS node group. So we're just creating the node group and we're specifying the scaling. So I'm saying now I want to have one node, which is also the max size and the min size. So here you could say I want to have 4 nodes or whatever you need. And this depends on all those policy attachments. So now we firstly need to download the provider. We're doing this with Terraform init. Now we can go for Terraform plan. So the Terraform plan basically checks what it should create and what already is created and compares it and shows us what it's intending to do. So basically it's saying there are 30 resources to add, 0 to change and 0 to destroy, since we don't have nothing yet. Let me show that a bit more detailed. So for example, it says here we want to have an AWS root table with the EKS public name. And this will have this root block here and all these attributes. That all looks quite good, so we can have Terraform apply. This will run now for 15 to 20 minutes, but I will fast forward that for you. Let us try now to access the cluster. So first of all, we are updating the kubeconfig so that kubectl knows which cluster to use. So here's our node that we just deployed. Let me now also try to access or to show all the pods. There we go. In the beginning, I've promised you a bonus. You've now learned how to deploy a single cluster using Terraform, which is really cool for a test environment, for example. But in a real world scenario, you need several environments like dev, test and production that are deployed in the most similar way. Let me show you now how to implement this using Terraform. So I've created a new folder here, which is Terraform multi-environment. And there we're having 3 environments, dev, test and prod, and the module. So in the module, we're having the subfolder for the module EKS. So these files are basically used for all the three environments. And what we now have is variables. So in the variables we declare all the variables that are different for the environments. Let's check here the VPC. So for the VPC we don't have the name, we just have the variable VPC CIDR, which is declared here. VPC CIDR, which is nothing more than the CIDR of the VPC. And so I've done this for all the subnets. So the subnets now contain the CIDR block and the name for all the subnets. So these are the variables that we need to provide from that we need to provide per environment. Let us check now the dev environment. So here we're having the backend and the provider. So this is the backend for this provider or the backend for this environment. So I changed now the key to the EKS dev state, since this is the EKS cluster for dev. And I also created a new DynamoDB table for this EKS dev. The provider is pretty much the same. So as you can see here, we are having the same profile in all the environments. Since I'm only having one environment handy here, but you can also use different profiles so that you can deploy different environments to different AWS accounts. So let me go back to the dev. So here in the EKS test, we are only having one module, which is the EKS. So we are saying to Terraform, please take the module from the source modules EKS and provide these variables. So we're giving the account name, the cluster role name for the first role and for the second role, and all the other variables. So when we're doing this now and calling this, it will just execute what we have in the module but exchange the values for the variables. Let us now execute Terraform init. This will basically initialize the backend and update all the modules. So then we can issue the Terraform apply. Yes. So the class has been deployed. In the same way, we can execute Terraform apply from the test folder to create the test EKS cluster, or the same for prod. EKS will definitely make your app better, but is this good enough to really get rid of your software monolith or your legacy software app? Certainly not. So what else you need to look into? These are microservices, message queues and databases, cloud, CI/CD and team alignment. I've prepared a strategy session for that is worth 1,500 euros. You can apply now below to get this strategy session for free. So click now on the link below to get your free strategy session.